Welcome back once again, my friends, and now we're going to talk about how we can solve quadratic equations by looking at the discriminant and deciding how many possible solutions. Of course, there's always going to be two, but what kind of solutions they are going to be. All right, so we have the quadratic formula, which is x equals minus b plus or minus b squared minus 4ac over 2a. We know that. Okay, now what we're going to look for is that number that is under the radical sign, not including the radical sign, just the number under the radical sign, b squared minus 4ac, and that is called the discriminant. Not discriminate, the discriminant. So make sure you know how to spell that. I'm sure there'll be a quiz on that at some point in time. So there are three possibilities. The discriminant can be positive, which means it's greater than 0. It can be equal to 0, or it can be less than 0, which means it's negative. Positive, negative, 0. Those are the three possibilities of what that value is. So let's take a look at what happens when the discriminant is positive or greater than 0. If that happens, then you will have two unequal solutions. Might be 2.5 and 4. It might be 6 and 10. It might be an irrational 2.3333456, or something like that. But there are going to be two unequal solutions. If it is equal to 0, there's one real solution. Now, that might not sit well with you because there are always, two solutions. But if you consider a perfect square trinomial that is like x squared plus 2x plus 1, that's x plus 1 times x plus 1. So that would be what the solution is, x equals negative 1 in that case. And we'll go over that a little bit later. Okay, and then we have, if it's negative, well, you can't take the square root of a negative number in the real number system, so we have to use the imaginary number, so you'll have two imaginary solutions. Let's see what this looks like graphed. You know that a quadratic is a parabola. So if we have two unequal solutions, that means that parabola is set either opening up or opening down, but it crosses the x-axis, so it has two distinct solutions. If it is equal to 0, that means that it either sits on the x-axis or hangs like a bat from the x-axis, but it only touches the x-axis in one point. And in this case, the reason for that is if it's equal to 0, then you don't have anything under the square root sign. So you're going to have minus b plus or minus 0, which is not going to change the value of minus b. So it's just, and then when you divide it by 2a, you're still just going to have b over 2a. So that's the reason for that. Okay? If it is two imaginary solutions, that means that the parabola either is above the x-axis and opens up, or below the x-axis and opens down. It never crosses the x-axis. Remember, solutions to quadratics can be called solutions, they can be called zeros, or they can be called roots. Anytime, anywhere that it crosses the x-axis. Okay, little review. Now, some additional information that I want to give you. If b squared minus 4ac, the discriminant, is greater than 0, then we need to kind of take a look at what the other what the possibilities are. Okay, if b squared minus 4ac, what's under the radical sign, is a perfect square. If it turns out to be 1, 4, 9, 16, 25, 36, something that is a perfect square, then you're going to have two unequal rational solutions. Rational solutions, a rational number can be described as two integers, one over the other, as long as the denominator is not 0. All right, and if it's not a perfect square, let's say that it is 12. Then when you take the square root of that, it's going to be 2 times the square root of 3, and obviously the square root of 3 is an irrational number. So anything other than a perfect square is going to be irrational. There will be two unequal rational solutions. It's still going to cross the x-axis in two places, but not at rational numbers. Okay, let's look at example number 8. we're gonna talk about the discriminant and the type and number of solutions that it will provide us. Okay, so if we have 3x squared plus 4x minus 5 equals 0, our discriminant, which is b squared minus 4ac, is going to be 16 minus 4 times 3 times minus 5, which is positive 76. Now think about positive 76. It's positive, so we know we have two solutions, but 76 is not a perfect square. So we will have two unequal irrational solutions. And our next example, 9x squared minus 6x plus 1, our discriminant is 36 minus 36, which is 0. And if it's 0, that means we're going to have minus b plus 0, minus b minus 0. Doesn't change that. So we have one, what we call a repeated solution, or a double root. And this turns out to be describing a perfect square trinomial. Now take a look at this. 9x squared minus 6x plus 1 factors into 3x minus 1, the quantity squared, which is a perfect square trinomial. Okay, let's take a look at another one. 3x squared minus 8 plus 7 equals 0. Our discriminant is 64 minus 4 times 3 times 7, which is 64 minus 84, which is negative 20. Now we have a negative number, so we know that we're going to have imaginary roots. Two imaginary solutions. All right, go ahead and do your checkpoint number 8, and we are done. See you next time.